Go live. Got it. Okay, so let's do this. Hi guys, can you hear me?
Yes, we
Yeah.
can hear you.
Amazing, amazing, amazing. All right, so let's get the show on the road. So please feel free to interject at any point if you feel like you have any question. Hi, Marianne. Feel free to stop me and ask any question. I am more than happy to actually answer those questions for you. I have Blessing on the call, who is going to be my co-host, and she's going to allow your other colleagues into the call. But without wasting much time, I guess we should get the show on the road, right? So welcome once again to another live learning session. Just as we do always, we are going to take a deep dive into the concept that we need to understand, to actually appreciate Python as a programming language and how we can leverage on Python to solve problems, okay? So last week we did take a look at classes and objects. Today we will take a bit of a look at classes and objects again. If you have any questions on it, it is important that you stop me and then you ask that question so that I can actually clarify for you. I guess we are live. Blessing, can you please share the YouTube link on the chat, just for the people who would want to follow on YouTube? Thank you. So as I was saying, we are going to look a bit more at classes and objects again. There we'll look at a very important concept in Python, which is inheritance. And then one more that I did add on here, which is polymorphism, okay? Without wasting much time, I'm going to escape from this. I'm going to minimize my browser, and I'm going to switch to my editor. Please confirm if you can see my editor. You can give me a thumbs up. You can just send me a message on the chat, or you can even unmute and tell me, hey, I can see your chat. I can see your screen. Great. So last week, we got to a point where we're talking about private variables. I believe we have all had a chance to actually go through the resources on the internet. We've actually looked at classes on the internet, and we actually appreciate the concept of classes and objects. Going forward, you would realize that many of the things that you will be using in Python are basically you creating instances of a class, okay? From you using a list to a tuple to creating variables that host numbers, strings, and all those data types that you use in Python would be some sort of object. As well as we progress through the program where we would actually be building real life applications, you would also realize that you will be making a good use of, guys, please hold on a second. All right, guys, sorry. As we progress through the program and start to build realistic applications, you'll always also see that you will be importing a lot of classes, which is third-party classes that have been written by other people that you can actually leverage in your programs. Without wasting much time again, let me see. Okay, so we have everybody here. We have most people here. Okay. So what are private variables, as you might be asking? So in here, from last week's session, we had this phone class where we had an initializer or a constructor that accepts one parameter, which is the name. In actual sense, it takes two parameters, right? The self, which is the default parameter that you always need to pass to a method that exists in a class, and then the name, which is the second parameter. In here, as I was explaining from last week's session, sometimes you have some variables in your program that you do not want people to have access to. Just as I said, your class can be designed to be used by yourself, or it can be designed to be utilized by others. Okay, so you might be compelled to create some kind of variables that you do not want other people to have access to, which is to say those variables and methods should only be accessible in that class, okay, and not outside of that class. So we had a phone class that has the constructor, and then we have two variables in here, the name variable, the name instance variable that actually assigns a value from the user or from the constructor, and then we have a battery health, okay? Now, the example I gave from last week was that imagine you've created your phone and the battery health can be changed by anyone or can be accessed by anyone, right? It won't be very useful. It won't be a very useful system. So you want the battery health as it degrades, you want to keep track of it and not allow people to easily change it. Okay, that will be one good use of a private variable. So we created an instance of this variable, this phone class as phone1. Then we tried to actually access the variables or the instance variables in this particular class. So from this session, I'm going to close this. From this section here, we have an instance of the phone variable, okay? And then we are saying that we can actually access the name instance variable of this class, right? So when I execute this code from my console, which I'm going to pull up a bit, clear the screen. From my instance variable, okay, you can see that it is actually printing out the name or the instance variable of phone1, okay? Now, we do have battery health here, so let's try to actually print out battery health. Okay, we need to actually follow the rules. So this is how it's been declared. Let's save, let's try to execute this. And right here, you see we get an attribute error. It tells us that phone object has no attributes, __ battery health. Did you mean this? Is this clear, guys? Hello, guys. All right.
We can hear you.
Great. All right. So I want to know, are you following? Hi, Andrew Junior Ampon. Hi, Andrew. Andrew, can you unmute? Okay, I guess Andrew is a bit shy. Okay, let's see. Emmanuel. Hi, Emmanuel.
Hi.
Hi, Emmanuel. How are you doing?
I'm fine, and you?
I'm good. Emmanuel, are you following the session?
No, of course, but I'm just joining soon.
Is this your first time ever joining any one of our sessions?
No, it's not the first time.
Okay. Did you join last week's intro session?
Yes, I joined.
Okay. Did you understand the concept of classes and objects?
Yeah, I really understand that.
Great. So do you understand the purpose of us trying to access the private variable in this class?
Can you, pardon?
Do you understand the essence of us trying to access on line 135, the private variable?
Yeah, I understand, yeah.
Okay, all right, good. So do you have any questions concerning this?
The question can be that in terms of the functions on line 223, like 123, yeah.
Okay.
Yeah, 123. Yes,
Okay.
can we beg for help using the same Python programming?
Come
for
again,
the
can you beg for
function.
help?
Yeah, begging for help to know
Yes.
the right function to use
Yes,
and
so you can
function.
you can ask me for any help. So what help do you want?
Uh, just like want to understand really what the diff means and
Okay.
what can you do with the diff. Can can you hear
Okay.
me?
All right. Is it just me or did you might not break out a bit? I can hear
Okay.
you. Can you hear me?
Yes, I hear.
Okay. All right. So if I get your question right, you want to know the essence of the def keyword here. Is
Yeah.
that right? Okay.
Yeah, is that
So I'm going to give you a quick overview or quick run through of it, but I would also entreat you to actually visit last week's intro session where we actually did a deep dive into classes and objects, okay? But even more
okay?
so, we've also in the past done a session on functions, okay? So I would really
Yeah.
appreciate if you can go back to the Python concepts for functions and look at that, watch that particular session, okay? It would bring you up to speed. Is that
Oh,
okay?
sharp. Okay, yeah.
Great. So,
Thank.
from what you're asking, from what I 123, it is not a function, okay? Like 123 is actually a class, okay? And as I said from last week, I said a class is a blueprint that specifies properties and methods that a particular instance can possess, okay? So, assuming you want to build a house, and you might not confirm if you can hear me, assuming you want to build a house, you would need some kind of architectural diagram or architectural plan to understand how the building would actually look like. Okay. Guys, hold on a second. Sorry, guys. Denzel, I'm still here. I'm still here. Sorry, I just had to attend to something, but I'm still here. All right. So as I was saying, so a class is just a blueprint. So assuming you want to build a house, you need a plan. Okay. So the class provides you with a plan that tells you how many bedrooms are you going to have in the house, how many sitting rooms or halls are you going to have, how many kitchens are you going to have, where is your toilet and bath going to be situated in the house. Okay. So basically, a class is just a blueprint, right? And out of the class, we can create an object. Now, from last week's session, I did mention that in Python, you can create classes by using the class keyword followed by the name of the class you want to create. So, Emmanuel, I'll actually entreat you to go back and then watch the previous session, okay? All right. Hi, Denzel.
Yeah. Hi, bro.
Hi. So Denzel, I want to ask you a question. So do you understand the essence of us having this private variable or private member in the class?
Yes, I do.
But do you think it is actually private?
Yes, it is private until you have to do something to get it.
All right, great. So to a large extent, in many programming languages, there are private variables that exist in a class that actually prevent other people from outside of that class to have access to that variable. Okay. Now, in Python, we don't actually have anything like concrete private classes, because if I want to access this variable, I can easily do this, okay, underscore phone, underscore, then the name of the variable, and this is actually going to give me access to that value. Do you see that?
Right.
Which means that that variable is actually not private, okay, because if it is private, I shouldn't be able to access that variable in any way, shape, or form. But in this case, in Python, we can actually do this to access the variable. Now, with that being said, if you have a private variable that you've created, presumably that you don't want people to have access to, then, or you don't want other programs or even someone else using your class to have access to, but you want to give them a right way, maybe the assumption here is there should be a way to actually get this this variable, right? Then you can look at getters, okay? So we have something called getters and then setters, okay? Setters. So using this concept, you can actually define a function that will get battery health, okay? Battery health. Okay, now remember this thing. When you declare a function without the self keyword in this, it is actually a normal function. But if you find your function in a class and you have to pass the default first argument, which is self, then this becomes a method, okay? It becomes a method. So a function that exists in a class is actually called a method. Okay, so now we can return self dot battery health here. Okay, now in this case, we are actually giving access to the battery health using a getter. So this is the right way to actually get access to it. So in that case, if I come here from my phone objects, which I'm going to comment this out, I can print this and say phone1 dot get battery health. Okay, now if I do this and execute this code, it is going to give me the results. Essentially, what it means is that you have created a variable that is private in this class, right? But you've also made possible a function that can actually, or you can use it as a medium to access that variable, okay? So something like this, if you use the get battery health, that is actually going to return that variable to you, or the variable content, then that becomes a getter. Okay. Hi, Priscilla.
Yeah, cool. Please, I just want to clarify. So when you run the code and you had the error asking you if you meant putting phone underscore battery, that one makes it doesn't make it private, but rather underscore battery underscore health makes it private, right?
Okay, yes. So if I get you right?
Yeah.
In here, when I run the script, it tells me that there's no attribute that exists as underscore battery health.
Yeah.
But you and I can see that we've declared that variable in here.
Yeah.
This, to a large extent, is trying to create a concept of privateness, right? Or privacy for this variable. But in Python, just as I said earlier on, you don't really have something like that. So you can see that after I created a getter, right, it is actually asking me, did you mean get battery health?
Okay.
Which means that the right way that I should be able to access that private variable should be through this getter.
It's okay.
Okay. And getters are just ways that we can actually use to get access to variables in classes. This is not particular to just private members or private variables, but it could be any other variable as well.
Okay.
You can create a getter that actually gets that value for you. Okay.
Yeah.
So that was what happened there. You're welcome.
Okay.
All right. All right. So now that we have this here, okay, we can have a getter for the name as well. So we can define def gets name, and then say here we're going to pass our defaults. Remember, always pass your default self in the class, and then we're going to return self.name. Okay. So in here, now we can actually access that method via the object instance that we've created. So we can say phone1.getName, right? Instead of using the name variable direct. So get name. So if I do this, it's going to give me iPreci as the name. Okay. As well, we can have setters. Hi, Andrew. Are both getters and setters always going to have self as function parameters? Andrew, not just the getters and setters, but any function that you write in a class would always have to have a default parameter, which will be the self. It always has to be the first parameter that you pass to that function. Okay, great. So we can have another function for the setter, and we're going to say sets, okay, battery health. Okay, so this is the right way. We are saying that if you truly want to change the battery health, use this particular method. Okay, so what will be the value? And we're going to say self.__ battery health, and we're going to set this to value. Okay. Now, setters do not return anything. They just set a value. Okay. So when I run this code now, sorry, okay, I'm going to comment this out. I'm going to use the instance variable phone1.set battery health, and I'm going to say set the battery health to 89 because we've been using iPreci's phone for quite some time now. So the battery health is actually degrading. Okay. Now we can check to see, let's use prints here, if that battery health has actually been set. So we're going to use the phone instance, there's a get battery health, and then we save. Okay, Kwabna, hold on. I'm going to answer your question. I'm going to clear my console, and I'm going to execute the scripts, okay? So now we can see that the get battery health is actually getting the new value that I set to the battery health via the set battery health, which I spelled battery wrong. Okay, so let me just correct that. Let me correct that here. Okay, so we can actually set that value, and we can get that get the value back using the setters and getters. Kwabna says, hi, cool. Please, are both getters and... Oh, sorry, I already answered that. All right, I already answered that. All right. So that is about it for getters and setters and about private members. But also, can we have private functions? Yes, we can. If we can have private variables, then we can also have private functions. And this is just like this. So we're going to say def and say charge battery. Okay. So this is going to be an internal method, self. And then we're going to say print charging battery. Okay. And we're just going to say if it's charging the battery, then let's just get the battery self dot battery health, and then we're going to add 1 to 8. Okay, so class equal to 1. All right. Okay, so charging battery, and then we're going to just show the current battery health. So self dot __ battery. Oh, sorry, I thought I was using F string. Here dot formats, and we're going to do self dot __ battery health. Yeah. Okay. So now we have this method, which presumably is private. Okay. So let's try to access that method using the phone1 instance. So phone1.__ charge battery. So let's see what happens. Do you see that? I get an error. It tells me phone objects has no attribute _ charge battery. We do see that we have that method in here. So essentially, if you have some variables or some methods that you want to only be accessible in the class, then please just use the private members. But as I also said, it is not always entirely private. Okay, so there's that. Any questions up until this point, guys? Any questions up until this point? Okay, so if there are no questions, I'm going to ask questions, okay? Hi, Danny Bliss. Hi, Marianne.
Hi, Cole.
Hi.
I do have a question. I actually don't really get the concept of this privacy, because is it that this get setters and discharge batteries, are they like the what's making it private? I really don't understand what exactly is.
Okay, so hold on. So hold on. Don't mute yourself, right? Okay. So the whole point is that when you create a class, okay, that class can have some properties and some methods. Do you understand up to that point?
Yes, I do.
Okay, so now there are some properties that you would want to make them private, okay? Because every property that you have in a class can be accessed from outside of that class or the instance of that class, okay? So for example, we have the phone class here that has a couple of properties and methods, okay? Now, the first property that we see here is name. Now, if we create an instance of the phone method, the phone class, right, then we can actually access that property called name, because name is a property of that class. So long as we create an instance of that class, we have an object. So that object in hindsight has a property called name. Is that okay?
Yes.
So if it has a property called name, then if I'm utilizing that object, I should have the capability to be able to invoke or access that property. Okay. So that is the whole concept of properties in the class. So take example, like you have your house, okay? And in your house, you are saying that, hey, in my house, everything that you see outside, right? You can see my house, you can see the properties of my house, you can see the doors, you can see my car parked out there, you can see maybe my cooker outside, you can see my generator outside, you can see all those things, right? We are saying that some of these properties you can access them, okay? But in that same house, okay, wherever you have the door closed, anything that is behind that door, you shouldn't be able to access it. So those ones are private. So for example, your couch that is in your living room is private. Okay. Your television, your bed, your wardrobe, your whatever that is in your room that is actually locked is private. Does it make sense? So in that case, I'm just using that same terminology here, okay? That we have some methods that are private that we don't want access from outside. For example, the battery health, it should be private inside of that object. You should not be able to have access to that variable outside of the object. So just like how we can easily use the dot notation to access the name property, we cannot do the same for battery health. Does that make sense? Because battery health is private. I'm just saying that battery health is private. I don't want you to be able to access it. Does it make sense?
Yes, it does.
Okay, but if in an event where you really need to access my couch in my room, or you need to access the television in my room, I'm saying that I'm giving you a permission, and you have to ask the right person. That is the whole purpose of the getters and setters, okay? So the getter here is for you to actually access the television in my room, I need to ask permission from you, Mary, that, hi, Mary, can I have access to your television? Mary, because Mary owns the television, Mary can give me access to the television easily. Does that make sense?
Yes, it does.
So the getter here is playing the role of Mary, saying that in as much as this particular variable is private, this method here, if you access it, it will give you access to that private variable. but you cannot have direct access to that private variable outside of the object.
Okay.
Okay. I know it takes a bit of getting used to for you to actually understand. That is why I was asking if anybody has questions, because you need to ask questions for you to get the clarification.
Okay. And so,
Right.
so does it mean that like the Python just makes some things to be private because we just declared a property and then it's already private on its own. We didn't make it private.
So it is not private on its own. We made it private by actually prepending it with double underscore. You can see this underscore.
Okay.
This double underscore actually makes it private.
Okay.
Does it make sense?
Yes,
so you can
does.
see the difference between the battery health and then the name. You see? So by using the double underscore, it becomes private. But if you don't use the double underscore, it is public.
Okay.
Okay, the same thing can be said for methods as well.
Okay.
Does it make sense? Hi, Kenneth.
Yes, it does. Thank you.
You're welcome.
So, hi, Cole.
Hi, Kenneth.
Yeah, hi, Cole. Can you hear me?
I can hear you.
All right. So I wanted to put this in perspective. There are sometimes I go online, I see a video, I want to download them, and I can easily copy the URL and download it. But sometimes when I click on it, I don't see the URL to download such a video from the platform. Is this actually what is being used to do such a thing?
I wouldn't say in its entirety that is what is being used, because whoever did that implementation might have used different mechanisms in implementing it. Okay, so I wouldn't say it's in its entirety that is what is being used, because I don't know the technology that person used. I don't know the approach that person used. Okay, but this is a way for you to understand that you can actually isolate some of your properties away from the people who can actually have access to it.
Okay, all right, thanks.
All right. Hi, Denzel.
Yeah, so just a quick one. In this case, we have battery health, and then we have what phone name. Is there an efficient way to like get both what do I call them, methods?
Get both methods?
Yeah, because like I mean get both values, because in this case, if I want to now get what you did later on, not for the battery health, I think it was the last one that you did, charge battery. Yeah.
Okay.
So if I want to get both the name and then charge battery, do I have to set another getter for charge battery as well?
No, so that is what I explained last week. So there's a default, and I don't know if I get your question right, but there's a default method called str here. Okay. So this str essentially whenever you create an object, right? The object should be able to define itself. For example, if I say print phone 1 here, okay?
Yeah.
Phone 1 here. This object that I have created here from the class phone should be able to describe itself. So now if you check the console, if I execute this, it will tell me that it would make an attempt to describe itself, but this will not make much sense to you. What it?
Yeah. Yeah.
So now I can now use the str method, okay? So like this, okay? Str here. And then I don't confuse you with this. So for now, let's do this. And I can say this would actually return. So if I want the name and I want the battery health, okay? So I can say phone name is this.
Okay.
And then the battery health is also this, okay? Then I'll do dot format here. Then I'm going to put self dot, what's that? Self dot name here, and then and I'm going to say self dot battery health like this, okay? So now
but in this case, I want that for charge battery, since we haven't been able to.
Okay, so the current battery health is this, and then let's say the charge the charge, okay, so let's say charge value will be this, okay? So let's do this here. And then now here we can do self dot charge battery here. Okay. So now if I ask this phone to actually describe itself, okay, on line 164, and I'm going to execute the scripts, we get this coming out here, right?
Yeah.
Now, what you are going to see here is this. So you see the charge battery here. You see what is printing? Good.
Yeah.
So if I want to get this, then ideally I need to actually use this method in here. Okay. So there's charge battery here as a method. Okay. So I need to call this as a method, not as a variable. So you see the difference between methods and variables. So now if I execute this now, it would now give me this value here. Okay. So let me just clear the console and then run the script again. Okay, so now you can see charge value is none. Okay, it's telling me charge value is none. Okay, because it's supposed to return something, but it's not returning anything. It's just I'm going to print something. So now let's comment this out and let's return this here to make life much more easier and say this should be +1 here. Okay, so if I execute this now, you see that it is actually returning the charge value to be 91. Do you see that? Yeah.
Okay. So what you're saying is that this method helps you get something that's private already.
Which one, the str?
Yeah.
No, the str actually helps the method to describe itself. But if you want to use a private method in here, you can literally use the private method in here. That would work. Okay, you can do self charge battery here. Okay, that would work.
Okay.
So anytime you're checking the battery health, it would actually charge the battery.
Right.
You can do that.
Right. I get you.
All right.
All right. Thank you.
You're welcome. Let me see here. Okay, Priscilla, do you have a question?
Yes, please. When do you decide to make a method private? And if you make a method private, because you're able to access it, so it doesn't really make it private because you're able to access it.
Hello?
Yes, can you hear me?
Hi, come again.
I was saying that I have two questions. When do you decide to make
I was able to access this method? No, so you can access a private method inside the same class, but not outside of the class.
Okay.
So if you are in the same class, then you can access the variable or the method. But outside of it, you can't. For example, if I come here and I try to do __ charge battery like this, it won't work. Do you understand?
Yeah.
Okay. All right. Great. Okay. All right. Okay, guys. So so this is why last week I said I wasn't going to get into it because I know it's going to be quite a topic, but we still need to move on. Okay. It takes a bit of practice and a bit of getting used to actually appreciate what this is about. Okay. And hi, Simelo.
Hello, Cole. Sorry, right before we move on, I just wanted to ask, can we use the same method for our protected attributes as well?
Come again?
So we're applying this method for private attributes, right?
Yeah.
Can we do the same for protected?
So Python doesn't actually have protected methods.
Okay.
Yes. Other languages like Java do. PHP, C++ all do have protected variables, but I'm not too sure about Python protected. I've had to use protected variables in Python.
All
okay,
right.
So you can actually look into it.
Okay.
All right.
Okay, thank you.
All right. Okay. So okay, so I just did a quick check. Hi, what was it? Simelo. So protected variables are the same, protected members are the same as the private members in Python. Okay.
Okay.
They're the same thing. All right.
Okay.
So guys, so as I was saying, Python classes are so important because you will be using a lot of them and you will be writing a lot of them. And they actually make life so much easy for you. But it is not always the case that you need to understand the inner workings of a class to use it, okay? So if you are just using a particular class, you don't have to worry about how it is actually working, okay? You just have to use it for the purpose for which you want to use it for. But when you are writing it, then you have to worry about how you actually write that mechanism for it to work inside of that class. Okay, and then any other person who is going to use your class will not have to worry so much about it. Now, there is a concept called inheritance. Okay, now I know this is a very popular term that everybody here on this call have heard before. So I am going to ask Simelo. Hi, Simelo, can you come back? What do you think is inheritance?
From what I guess understand inheritance to be, it is to bring something from another thing or to take something from another thing, to inherit something. So maybe inheriting classes from other classes perhaps could be an example.
Amazing, amazing. Anyone else wants to try? Hi, Nancy. Philip. Hi, Philip. You can try.
Hello.
Hi.
Okay. I think to inherit is maybe you want to have a class which you will inherit from another class, which will be the base class of where you want to inherit some properties.
Okay. Okay. I think that is a very good try. Nancy, are you here? Nancy Ofuri. Hi, Nancy. Okay. I guess Nancy is a bit shy. Prudence. Hi, Prudence.
Hello.
Hi, Prudence.
Hello. I think inheritance.
Hi, Prudence. Hi, Prudence.
Can you hear me?
I can hear you.
Yeah. So inheritance is whereby there are two classes, or one superclass and other subclasses that use or derive characteristics from the parent class.
Amazing. I think that these are all very good answers. But I think your answers are a bit too abstract. Okay, so let's bring it down to a level where we can all actually appreciate what inheritance is. So the simplest form, I remember way back in college, one of my professors was trying to explain inheritance to us, and this was how he said it. It was like, you are, let's say you are a girl or a boy, whatever. Okay, so your father gave birth to you, so you inherited traits from your father. Okay, so simply that is inheritance. So when your mom and dad give birth to you, okay, you inherit some traits from them. It could be your height, it could be your shape, it could be your hair color, it could be your eye color, it could be the shape of your nose, it could be anything that you can actually inherit from your parents, right? So that is basically inheritance. But that is not such a good explanation of inheritance because we cannot actually put it into perspective. So let's see how we can actually put it into perspective. All throughout this session for classes and objects, we've been using the phone method as phone class, okay? So I'm going to grab these methods from here. So let's copy these properties here. Okay. So phone, we're going to have the phone class with some comments here. Let's just put this here in the class documentation here, so we don't need this. This one's here. Actually, let's see if we can format this properly. I don't have my Python formatter. But anyway, so let's do this. Let's do that. Let's do that. Okay. So now, if you remember from last week's session, I made mention that a class is a blueprint, okay? And what the blueprint is, it gives you an outline of what properties and methods that particular class can have. We used the phone analogy, and we said no one here on this call is actually using a phone. Everybody on this call is in one way or the other using an instance of a phone. So every phone that you actually see, regardless of the brand or model that is, could have some properties. So let's come here and declare our initializer, okay, and next, okay, and next, if I can spell correctly, okay. Now, in here, we're saying that every phone can have a name, okay, and color, and let's say weight, okay, that's all. So in here, we can have some instance variables and say name that assigns name, color that assigns color, and then weights that assigns weights, so the weights that assigns weights, okay? Every phone can have these properties. But as well, every single phone out there can make a call, okay? So def make call, okay? Not you, so we say this here, and then we say prints, making a call, right? Every phone has a ringtone. So let's see, ringing tone, okay, yeah. And then we'll say prints, and then we know every phone ringtone makes some noise, okay? So make some noise like this, okay? This is a basic class that we've created. Now you can replicate this for any object that you want to module. It could be an animal, it could be a soccer player, it could be a television, it could be a house, it could be basically anything that you want to model as a class. Okay, so long as you are able to identify the properties and methods of that particular object, then you can model it as a class. Now, these properties and methods that we've created is generic and it's not particular to any phone. Okay, so now we have a company called iPrezi, okay, but now instead of iPrezi, we're going to say Samsung, okay. Samsung is a particular model of a phone. So if Samsung wants to create a phone, they are just going to create something that would have name, color, weight, can make a phone call, and will have some kind of ringtone, okay. So Samsung can actually inherit from this phone class. So we can create a class called Samsung, okay, Samsung phone, okay, let's add phone to it here, and then let's put a pass here because we don't want to define this. Now, this Samsung phone is a phone. Actually, let's take out the phone to make it look a bit more realistic. Samsung here is a phone. So Samsung as well would have some properties and methods. Now, the easiest thing we can do is that Samsung can just go here, copy the entire properties and methods of this phone, bring it here, and then just paste like this, okay? And you can see, because of the indentations, I'm going to get some errors, so I need to indent properly, okay? Like this, and like that, okay? So Samsung can easily say that, hey, we are going to create our own mobile phone, right? And in our mobile phone, we also need the name, color, weight, model. We can also make phone calls, and the phone would have a ringtone. But there is a problem here. You can see that all that Samsung did was they just went up here and then copied every single line of code and then just brought it into their class. That is not very efficient. This is where inheritance comes into play and makes life much more easier. We don't need all these things here. With inheritance, Samsung, being a type of phone, can just inherit directly from the phone class, okay? Like this. So by using this annotation, we can pass the parent class or the base class, which is the phone, to Samsung, and then automatically Samsung would inherit all the properties and methods of phone. So let's put that into perspective. So I am going to create an instance of a phone, okay? So phone 1, and this will be phone. This is going to take a name. Let's call this iPreci. Okay. It's going to take some color. Let's call this golden. Let's have another. We have weight. Let's put 45.9. And that's all, right? If I do phone dot make call, we can see that phone dot make call would actually make a call from our console. Okay, so I'm going to clear out the console. I'm going to close this again. But as well, we can create a Samsung model called Galaxy, okay? And then this will be of type Samsung, okay? Now, because Samsung is inheriting from the base class phone, all the properties and methods exist in Samsung. But we can see in Samsung, we have not defined anything whatsoever in here. So in here, because Samsung is naturally or default inheriting from the phone class, we can actually pass the details that we want here. So we can say Samsung Galaxy, okay, like this. Give it a color, let's say matte black, okay, like this. And let's say this is 56.8, and that is it. So we can say Galaxy dot make call, and then let's see what happens, okay? So now you see it is working as expected. One thing you need to appreciate here is that class Samsung has not defined any properties and methods, but by the power of inheritance, it is actually inheriting every property and method from the phone class. Therefore, we can treat Samsung as though it was a phone because literally it is actually inheriting from the phone class. Any questions up until this point? Hi, Bawa. Hi, Bawa. Okay. Hi, Kenneth. Okay, Bawa, you're finally back?
Yeah.
All right. Do you understand and appreciate the inheritance properties of object-oriented programming?
Yeah.
Do you see how easy it makes it to actually, you do not have to rewrite the entire code all over again in your new class, but you can literally inherit everything from a base or a parent class?
Yes.
Good. Do you have any questions around this?
Actually, I don't have any questions.
Amazing. All right.
Okay.
Cool.
I wanted a one-on-one discussion with you, but
okay,
I don't know.
Okay. So what I'll do is I'll have Blessing reach out to you, okay? And then she's going to share my my Calendly link with you so that you can actually book a session with me.
Okay.
You can book a one-on-one session with me. All right.
Okay. Thank you.
All right. Okay. Priscilla, do you want to unmute and ask your question?
Yeah, please. I wanted to find out if you can inherit from a different file, maybe in the same folder, but.
So by different file, what do you mean different file?
I mean different.
I want you to use the right word. I get what you want to say, but I want you to use the right word because we've already covered that concept.
Oh my goodness.
I got you there. Okay. So I get what you mean. You're saying that, okay, if I have a folder here, right? Let's call this folder projects. And in this folder, I have two classes, okay? Okay, can you hear me?
Yeah.
Can you hear me, Priscilla?
Yes, please.
Okay, and I have two files here. Let's call this phone.py, And then let's call this Samsung.py, right?
Yeah.
You are asking, if I have class phone here, and then it has some properties, right? And I have Samsung here, class Samsung here, right? Can Samsung actually inherit from phone?
Yes.
Right?
Yeah.
Actually, it can. You just need to say from phone imports phone, okay, like this. And then you can just pass phone here. Do you see that?
Okay. Yeah.
So you can actually import this particular class into the new file and then just inherit directly from it.
Okay. Thank you.
All right. You're welcome. Khadija says, why aren't we seeing the output of the first variable? Okay, Khadija, do you want to unmute and ask? Hi, Khadija.
Hi, Cole. Yes, I can. Okay. We've known about inheriting the properties from the parent class, but I'm wondering why we are not able to see the output of phone 1.
Wow. Is it just me or is Khadija breaking?
Hi, can you hear me?
We can see the output of phone 1.
It's
we can see the output of phone 1.
Can see making calls.
So I'm going to run this. So I'm going to run the script again. You can see there are 2 outputs, right? I'm going to clear the console and then run the script again. There are 2 outputs, right? So the first output is for phone 1, and then the second output is for phone 2. Do you see that?
It's making a call, yeah.
Yeah.
I can see that, but I was wondering why, the properties inside the phone 1 equals to phone Cypress Golden 45.9.
Yeah.
That's what I wanted to know.
You want to see the properties that we've declared here?
Yes.
Because we've not actually declared, we've not actually printed those properties. We are just calling the method.
Oh, yeah.
And what this method does is it just makes a call.
Making a call, yeah.
You understand?
Yes, I understand. And then the previous question, the one that Priscilla has asked, you say that you cannot copy properties from a private Nini. If the properties are private, that is. So can you really import in a different class that is outside class phone?
I'm confused with that question. Can you clarify on it?
Okay, so he initially said
so should I go back to this? Yeah. Let me go back here. I guess this is where it was.
You cannot use a private property outside of this class.
Okay.
If you make a Nini private by having the double underscores, right?
Yeah.
But then Priscilla has asked if we can have the same in class Samsung, which will be outside class phone. If you are importing these properties to class Samsung, is it a public?
So if I'm getting your question right, we are not importing, okay? We are inheriting. So even if the phone class has any private methods, the Samsung phone, once it's inheriting from the phone, will have that private method.
Okay. So even if it's outside of this class.
Yeah. So how is it outside of this class? This class, by this class, do you mean Samsung?
The one that you just created, this Samsung.py.
Oh, okay, here.
Yeah.
Oh, you mean this here?
Yes.
The project the project. Oh, if you have a private, if you have a private property somewhere, no, it's still the same thing. I get you now. So if you have a phone class here, which you have it defined with some private properties, and Samsung in this class is actually inheriting from it, it would actually inherit all the properties because the private property is still a property of phone.
Okay.
Do you understand? Yeah.
Yes.
Yeah. All right. Okay. So hi Marianne.
Hi, cool. So if we are to use this in like in real life situation, are you saying like, let me say Samsung can inherit a property of iPhone and then
no. Samsung, hold on. Samsung and iPhone are two different brands of phones, right? But they are all instances of phone. Do you understand? They are both phones. Okay. The only difference between Samsung and iPhone is their features and then their functionalities, right? But regardless of their features and functionalities, they are both phones. They are both mobile phones, right?
Yes.
They can all make phone calls. They can all take pictures. They can all take videos. They can all save pictures. They can all send messages. And these are properties of a phone. Those properties are not particular to just iPhone. You cannot say that iPhone was the only company that invented sending messages, right? These are properties that we have agreed that are part of a phone. Do you understand? A phone, a mobile phone. So regardless of the fact that you're using a Samsung, an iPhone, a Nokia, a Huawei, or any phone, these are all brands of a phone. Do you understand?
Yes, I do.
Okay, so this is programming in a nutshell. So you see, when it comes to programming, right, we are looking at precision. We are being precise with what we are seeing and what we are doing. So if we are describing something, we want it to be very precise. So if you are using an iPhone and I'm using a Samsung, we are both using mobile phones. I don't care if you're using an iPhone 15 and I'm using Samsung Galaxy 2. We are both using the same phone, right? Because both phones can make phone calls, it can take pictures, it can send messages, and so on. Do you understand? But the whole point for this session is that inheritance, if you have the phone being the base or parent class, you don't need to redefine the entire properties and methods again in a different class. If this class is a subdivision of this, right, then you can just inherit directly from the parent class. That is why I'm using as a good example phone, which we all can understand. Is that okay? All right. So in that case, then we know that Samsung here is a type of phone, okay? And phone is phone itself. All right, good. Now, I said that if you inherit from a parent class or a base class, then all the properties and methods of that class has been passed on to the child class. So I am going to ask Ali Tom. Hi, Ali Tom.
Yeah, hello, Cole.
Hi. So Ali Tom, so I want to ask you, okay, how are you doing? I think that's the first time we are speaking.
It's Fred.
Fred, come on, Fred. You're always using different names. Are you trying to confuse me? Are you trying to confuse me?
I'm sorry, I didn't log into my Zoom before I
Okay. Yeah. I mean, if your goal is to confuse me, you've succeeded. Okay, you've completed this. Okay, Fred. All right, Fred. So my question here is that this method, for Samsung, right?
Yeah.
Is inheriting from the class phone, right? So what would you say the Samsung is? The Samsung class? Is it the base class, the parent class, or is it the child class?
Child class. It's taking the properties of its parents. The parents is the phone.
Good. So we all agree that the base or parent class is the super class, and then the child.
Hello, are you here?
Hi, I'm here. Can you hear me?
Just showed us why Androids are a lot cheaper than iPhones.
Oh, come on.
Because with this, you can just easily copy the code and just make it.
Oh, that's funny. Okay, so at the end of the day, we see the essence of the base class and then the super class. But look at this. Samsung. Okay, so let's create another class again here. And this class is going to be called iPhone. Okay, and this is also going to be of type phone. So iPhone is also inheriting from phone, right? So we can create iPhone. Let's call this and say this is type iPhone. Okay. If I can spell iPhone correctly, let's say this is iPhone. Let's say 14. Let's give it a color. Let's call this purple. We have a purple iPhone, and then let's give it a weight of, let's say, 14.5. Okay. Now we have iPhone as well. Sorry, iPhone.make call. Right. Now we all know that the ringtones for iPhone differ significantly from someone has their hand up. Okay, hi Marianne, you still have your hand up? Okay. So we know that the ringtone of iPhone differs significantly from that of Samsung. So if both iPhone and Samsung are both inheriting from phone, then what happens to their ringtone? So let's check out Samsung's ringtones. We're going to comment out the phone one, because that's an abstract phone. So we are now focusing a bit more on concrete phones, right? The one that we know about, Samsung and iPhone. So let's say ringing tone here, and then ringing tone here. Now, because both phones, Samsung and iPhone, are both inheriting from the phone class, if we run this script, we'll see that they will both make some noise. But that is not a good characteristics of both phones, right? So we can say, we can define a ringtone for Samsung, okay? So let's define a ringtone for Samsung. Okay, we don't want this here. Okay, and we're going to say Samsung is going to ring, pam, 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 okay? And now let's define a ringtone for iPhone, ringing tone. We don't want that there, ringing tone. Okay, I don't want you to do this. Okay, and now let's do print here, and let's say tan, tan, tan. Because I have good voice, you can hear the way my Davido voice is coming out with my sounds, right? Okay, so now we have these ringtones, right? The phone, every phone can make some kind of noise because they have a ringtone. But Samsung ringtones are unique than that of iPhones, right? So if we are inheriting from a phone, that means all the phones can make noise. But then we can actually customize the type of ringtones that each and every phone has. So with this customization that we've done, let's see what happens when we run the scripts. So now we can see that Samsung is actually making a ringtone or a noise of pam, pam, pam. And then iPhone is making a sound of tan, 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 right? This is what we, yeah, Freddie says he's beginning to feel like a programmer. Yeah. Okay. So you see, we have been able to actually customize the ringtone for each and every mobile phone, right? In as much as all mobile phones can make some noise, we have customized the ringtones for each and every phone that is inheriting from that particular parent class. This is what we call method override, okay? Method override. Okay, so what is happening here is that the child class Samsung is actually inheriting the constructor of phone, the method make call, and then the method, Priscilla, yes, I just showed you how you can run your code, all right? And then the method ringtone, okay? If that is the case, yes, we can. If you define a function that exists in the parent class with the same name, the same method, sorry, the same parameters and arguments, then you're doing what we call the method overriding. Another thing that you need to note here is when you define a method with the same name, same number of parameters or arguments, right? This is called the method signature, okay? The method signature. So if you define a method with the same signature as that of the parent, you have overridden that particular method. So this is what we call method overriding. But at the same time, this also demonstrates the the concept of polymorphism. Okay, polymorphism. So does it mean that all methods and attributes that we don't want a class to inherit, we need to override them? Or not necessarily. You don't have to override them. If you inherit from a parent and you feel like there's a particular method that the parent possesses that you want it to act differently, you can override it. If you override that method, it would actually act differently than that of the parent, and that is what we call polymorphism, or polymorphism, right? That is the concept. Okay, that is the method would act differently based on the type of object that is created. So you see how I have explained method override and then polymorphism in the same context. This is polymorphism. Okay. Any questions up until this point? Any questions, guys? Our time is almost up. So, okay. So do you have any questions? Can you overload a function in the... So overloading is basically having a method that will have a different number of parameters than that of the original one. So yes, you can do that, Prudence. So override and polymorphism is the same thing. Not necessarily. Polymorphism is the act of that particular object or method acting differently. Okay, the method acting differently based on the object that was created. Okay, the overriding is just you changing or overriding the original method. Okay, so one is the act and one is the process. All right, great. So you see how interesting programming is. This is when we are actually doing programming. Okay, and if you put this into practice, trust me, you are going to enjoy your journey in programming. Programming is quite an interesting thing to do. You can define classes, you can create your own instance. Let me just put this into perspective. Imagine you building FIFA, right? Your own FIFA game, okay? You can create a class that represents the players, okay? You can create one class that represents a team, one class that represents a player. Then all you need to do is just create multiple instances of the players, okay? Then the only different thing that you see from creating the different instances of the players would be their agility, their speed, their jersey number, their height, and so on. So with the same one class that you create, you can create 11 players easily without having to actually worry about how each and every player is going to act. Most importantly, in your FIFA game that you will be designing, and forgive me if you don't know what FIFA is, it's just basically a game that you can play.
I have a very important question.
Please ask me, Freddie.
Subclass have multiple attributes.
Okay, come again.
Can a subclass have multiple attributes?
So yes, it can. So we're going to look at that in a second. So I just wanted to put it into perspective first, and then I show you how we do that. Okay.
All right.
So thank you for that question. So as I was saying, so you would realize that the instances of the players that you create will just be different based on the arguments that you pass to the class or the constructor. But also in your game, you would have some characters that are not players, but it could be a coach, it could be a linesman, it could be a referee, or it could even be spectators. These are all instances of human beings, okay, that you can just have one class, and based on the specification or the attribute that you pass, that particular character would act differently. So you see how easy and amazing life is? Great. Any question before I move on? Any question? Okay, good. So if there's no question, then I assume everybody understands. So let's move on. Freddie asked a very important question. He said, can subclasses also have their own attributes? Of course they can. Remember, I told you that whenever you inherit from a parent class, the subclass actually inherits all the properties and methods of the parent class. One of the methods includes the init method. The init signature here is actually a method that is called like by default, okay, anytime you're trying to create an instance of a class. So it is also a method, okay? So for example, for Samsung phones, let's see, what does Samsung have different? Okay, so we can define an init method here. We can define an init method here, okay? That takes the default parameter, which is self, remember, and we're going to pass here. Now, whenever you do this, this is what is happening. If the subclass also has a constructor, then you have already overridden the constructor of the parent class. So the init method of the subclass would act differently than that of the superclass. Okay, so we have this init here. So now this Samsung class that we have here, which I have to put some spaces here, okay, is going to act differently based on this init. But we know that it still has to get some name, has to take some color, has to take some weights, okay? But also we have an additional attribute we want to add, okay? Let's say place of manufacture, okay? Manufacture, okay? This is the only attribute that is different than that of the parent class. So we can actually do this, create our own Samsung place. Actually, let me copy and paste. Guys, don't copy and paste, okay? Let's go to place of manufacture here. This is the only thing that we need because we are inheriting from the base or the parent class. These parameters have already been initialized for us. So all we need to initialize, we need to create our own our own instance variable that would actually initialize place of manufacturing. Phone itself is an abstract concept. So there's no particular place where you can invent or manufacture phone. But Samsung is actually being manufactured somewhere. So we have the place of manufacturing here. Now, if that is the case, then how then do we initialize the instance variables of the parent class? There are two ways that we can do that. I'm going to show you all two. The first way will be to use the name of the parent class phone and then invoke the init method like this. This will take self, name, color, and then last but not the least, weight, okay, like this. If you do this, by default, Samsung is still going to inherit from the parent class phone, but you will be initializing the instance variables of phone, which is name, color, and weight, via the parent constructor. But also, Samsung has its own instance variable, which is place of manufacturing, which is actually different than that of the phone. This is one way to do it. The second way to do it will be to use the super method. If you use the super method, you can easily access the init method, okay? And then just pass name, color, and then weight here, like this. I need you to know these two, okay? The first one, note the difference. The first one here, you pass self to it. The second one, you don't pass self to it, okay? So by using the super method, you will actually be able to access the constructor of the superclass, okay? Now, for our Galaxy, we can actually pass the place of manufacturing and say this is India, okay? If we execute this, our phone still runs as expected. Let's clear the console. Let's execute this again. Any questions, guys? Any questions, guys? Hi, Charlotte. Hello, Charlotte. Charlotte, are you here? Okay, there's someone. Hi, Philip.
So if we want to add another property, we have to repeat the whole initialization first. Isn't there another shorter way of doing it?
So actually there are three. Okay, so there are three ways of doing this, right? But I actually taught you two. So I'm going to show you the last one. I think I've already showed you the last one from the previous concept, but I'm going to show you again. So it is not always the case that you want the Samsung phone to have these properties, okay? So for example, maybe you don't have these parameters, okay? In that case, you don't need to initialize this, okay? You just need this particular method added, okay? So one way you can go about this is you can set default values for this, okay? You can set default values for this, okay? So let's say this by default to be 0.0, okay? That way you do not have to necessarily use the super keyword and then pass all those methods here, okay? It will do that automatically for you. All right, and then the third method, which I'm going to undo this and then bring this back here because I don't want to type, the time is over, okay, is to use this approach. Philip, I hope I answered your question.
Yes. Yeah.
Okay. All right, guys. If there's no more questions, I guess I have covered almost everything on inheritance, at least for this level. So I would actually move on to explain one important concept that I need you to know. And then for next week's session, this Friday's session, I'll also add on another concept so that we understand it. Okay. You guys do know that we will be going on a short break, and during which period you won't be having any project released for you. So it will be a good opportunity for you to actually try and catch up on any project that you've actually not worked on. Okay. And if you have any thing that you want to learn, it will be a good opportunity for you to learn, because when we resume, we are going to move at a bit of a fast pace because we would assume that you already have this base knowledge. We are going to do a bit more practicals, and it's going to be amazing. Okay. Hi, North.
Hello, Cole. It's been a while.
Hi.
Cole, I sent you a message, right? But I didn't get you. But can you also get Blessing to reach out to me to like send me your calendar link? I would like to talk to you about something.
Okay. Hi, Blessing. Please speak to Not as well, so that you share the link with them. Okay.
Thanks so much, Cole.
You're welcome. All right, guys. So the last thing I'm going to talk about before I wrap up my session is scope. Okay. Now, scoping is a very important concept in Python and every programming language. Okay. And you need to understand it. There's two scope. Whenever you create a variable, one thing you might have already noticed is that in Python, or when you're writing programs, you will be creating a lot of variables, and you will be storing or persisting a lot of data. That data can be a string, it can be a Boolean, it can be a number, it can be a tuple, it could be a set, it could be a list, it could even be an instance of a class, which is an object, right? But there are levels to which you can actually access these variables when you create them. There are two scopes, which is the local versus the global scope, okay? So let's call this class, let's create class person here, okay? And then you create a variable person, let's go to person like this, okay? This person actually exists on a global scope, okay? It exists on a global scope. What it means is that if I create a function, now note the technical term that I'm using here. If I create a function that says initialize person, right? And this is going to initialize person to something. So let's say some name, okay? And we're going to say person, let's return a person and name like this, okay? This function that you create, everything that you create in here, let's say we have name here, let's say we have age here, 65 or 56, right? The variables that you create here in this function are local to this function or this block, okay? But everything else you create outside of the function is in a global scope. It is an important concept that you need to understand. If you don't understand this, then you will be having some challenges in terms of why am I not able to access this? Or why is it that when I'm trying to access this, I'm getting none as the value? Okay, so there's the global scope. Any variable that you declare outside of a block is global. That is, if you create a Python file and you create any variables outside of a particular function or class, it exists in a global scope. But if you create those variables or methods in a function, those variables in a function or those methods in a class, it exists in a local scope. Okay, it is a very important concept. So simple, but you need to know about it. This is why I had to bring it up. Any questions, guys? If you don't have any questions, then we can wrap up. Any questions, guys? All right, amazing. So there's no questions. We can call it wraps for the session. I need to bring this up. I need to just slideshow this. And I need to bring you guys back up.
Hi,
so guys, hi.
Please, my question was, instead of pressing on the run at the top, is there something like control something, or that was what I was asking?
Sorry. Hold on. Let me just bring back my stuff up. So you have the editor, right? So instead of clicking on this, you can also right click here, and then you can also run Python here. You can see that here, right?
Mm-hmm.
But then you can see here, I am using how do you call it, a Mac for now. So if you have any other OS, you can check the shortcut here. Normally the shortcut is written here. Do you see that?
Okay.
So this will be like Shift and Enter, okay, to actually execute the Python scripts. Okay.
Okay. Thank you.
All right. And if you don't have it, I think it's configurable enough for you to actually configure a particular shortcut to run the code.
Okay.
Is that okay? All right. Amazing. Okay. So let's go back here. Okay. Okay, guys. Thank you so much for joining the session. I really do appreciate your time and your effort. As I said, we will be going on a break soon, and there will be a good opportunity for you to actually catch up on every little concept that you might have missed. Note that we have come a long way from HTML, CSS, from the beginning of Python Hello World to Python Inheritance. Guys, we have gone a long way, but it would seem like you don't know anything if you do not practice. So I would actually entreat you and advise you to actually practice. Okay. Okay, that's fine, Alexa. Okay, so I'd actually advise you to keep on practicing. Okay. Good. So I have a couple of announcements. Please note that PLDs are a core component of this program, which means that it is important for you to actually learn and then be able to learn with your peers. It is also important for you to discuss with your peers, and because you get to learn from your peers. You don't only learn from your mentors or from books, but you also get to learn from your peers. Their view of it might be totally different from what I'm saying, but it might give you a better clarity on the concepts. So please join PLD tomorrow, which is Wednesday, December 13th, and contribute. Okay, and be very proactive in the PLDs. It will actually help you succeed in the program. If you have any challenge whatsoever and you want to invite me to your PLD, I am open. I am more than ready to actually join your PLD to provide you with assistance and guidance. Okay, and be sure as well to complete the projects released this week. Guys, please do that. So thank you so much for joining. I